through projects. In this video, we are going to explain about the project title, a hybrid blockchain based identity authentication scheme for multi-WSN. Introduction. The main objective of the project is to create an innovative identity authentication system utilizing a hybrid blockchain. This authentication scheme is designed specifically for multi-WSN with the goal of enhancing both security and efficiency in the process of verifying identities within these network environments. Traditional identity authentication systems within multi-WSN often rely on centralized architectures, making them vulnerable to various risks. These risks include single points of failure, susceptibility to hacking, latency issues, lack of transparency, and security breaches. By highlighting these challenges, the project emphasizes the need for a more robust and secure authentication mechanism. The project proposes the use of a hybrid blockchain, which combines the advantages of both public and private blockchains. By leveraging this hybrid approach, the system aims to enhance security, scalability, and efficiency in identity authentication. The blockchain helps reduce potential failure points and increase transparency, making the identity authentication process more reliable and robust within multi-WSN. The secure hash algorithm 256-bit is a cryptographic hash function that plays a crucial role in the project. It is used to calculate cryptographic hashes, enabling the validation of data authenticity at various stages of the project. SHA-256 is employed in processes such as authentication and data transmission, ensuring the integrity and security of the information exchanged within the multi-WSN environment. Objective. The primary goal of the project is to propose a novel identity authentication scheme utilizing a hybrid blockchain specially designed for multi-WSN in an IoT simulated environment. The focus is on achieving a secure and efficient means of authenticating identities in this context. In IoT simulated environments, security concerns, especially for equipment deployed in harsh conditions, are a critical consideration. The project aims to mitigate these concerns by developing a decentralized solution for authenticating the identities of nodes within the IoT simulated environment. This decentralization enhances security by reducing potential vulnerabilities and central points of failure. The project seeks to establish a hierarchical network structure within the IoT simulated environment. This involves categorizing IoT nodes into distinct levels, including base stations, cluster head nodes, and ordinary nodes. Concurrently, a hybrid blockchain model is constructed, likely incorporating both public and private blockchains elements to facilitate secure and efficient identity authentication across these hierarchical levels. Traditional identity authentication often relies on trusted third parties, which can be impractical or present risk in IoT simulated environments. The project focuses on developing a system that removes this reliance on trusted third parties for identity authentication. By doing so, it reduces the risk of a single point of failure and enhances the overall security and robustness of the authentication process. Requirements. The requirements of the project are hardware requirements, in which we have processor of Wi-Fi and above, RAM of 8GB and above, ROM of 25GB and above. Software requirements, in which we have Node.js, Python 3.7.0 version, and Visual Studio Community version. Methodology. To implement this project, we have designed the following modules. The first module is Sensor ID. The Sensor ID module involves assigning a unique identification to each sensor within the wireless sensor network WSN. These IDs play a fundamental role in the authentication and tracking of sensor nodes within the network. Generate Sensor Network. This module involves creating and configuring the wireless sensor network WSN, including the deployment of sensors and the establishment of network communication protocols and structures. Generating the sensor network is a foundational step to implement the proposed identity authentication scheme. The blockchain-based authentication relies on a well-structured sensor network to ensure accurate data transmission and secure identity management. Initialization. The initialization module involves setting up the blockchain network, defining its structure, establishing the initial parameters, and configuring the hybrid blockchain for use within the multi-WSN environment. Initializing the blockchain is a critical step as it lays the foundation for secure data storage and identity management. The hybrid blockchain must be appropriately configured to ensure the integration of public and private blockchain features, meeting the specific security and scalability requirements of the multi-WSN environment. Registration. The registration module involves enrolling sensor nodes and their corresponding identities onto the blockchain. This process securely associates sensor IDs with the appropriate sensor nodes. Registration is a pivotal step in establishing a secure identity authentication scheme. By registering each sensor node on the blockchain, the system creates a trusted and immutable record of the sensor's identity. This registration data is utilized during the authentication process. Authenticate and send data. This module is responsible for authenticating the identity of sensor nodes before data transmission, ensuring that only authorized and registered nodes can send data. It also involves the secure transmission of data over the network. Authentication and secure data transmission are at the core of the project's objective. By leveraging blockchain-based authentication, the system verifies the identities of the sending nodes, enhancing security and reducing the risk of unauthorized data transmission within the multi-WSN. Message size graph. This module involves creating a graphical representation, a graph that illustrates the size of messages being transmitted within the multi-WSN environment. It helps visualize how the message size may vary with different factors or stages of the authentication and data transmission process. Blockchain integration. The project blockchain technology is utilized for the registration of sensor nodes. Each sensor node is assigned a unique identifier, often a cryptographic key, which serves as its distinct identity within the network. This identity, along with other relevant information, is securely recorded and stored on the blockchain. The blockchain's immutability ensures that once a sensor node's identity is registered, it cannot be altered or tampered with, providing a secure and verifiable record of sensor identities. Blockchain offers a decentralized and immutable approach to identity management within the multi-WSN environment. Decentralization means that the identity records of sensor nodes are distributed across the blockchain network, eliminating a central authority and reducing the risk of a single point of failure or unauthorized alterations. Immutability ensures that once a sensor node's identity is recorded on the blockchain, it remains unchanged and secure, maintaining the integrity and trustworthiness of the identity data. The authentication process in this project leverages the blockchain to verify the authenticity and permission of sensor nodes. During authentication, the blockchain has access to validate the provided credentials and permissions associated with the sensor node. The stored identity and permission data on the blockchain are cross-referenced to ensure that only legitimate and authorized sensor nodes gain access, enhancing the security and trustworthiness of the authentication process. Blockchain enforces access control policies and authorization rules through smart contracts. Smart contracts are self-executing contracts with predefined terms and conditions directly coded into the blockchain. In this context, smart contracts automate the execution of access control policies. They define the conditions under which a sensor node can access specific resources or perform actions within the multi-WSN. This automation ensures that access control is enforced rigorously and transparently, reducing the risk of unauthorized access and enhancing overall system security. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. These are Python code files that will be executed during the runtime of the application, supporting its functionality. This is run.bat file. Instead of executing the project through command line interface, we have created Windows bat file to execute the project. Double click on it to start the application. This is the graphical user interface created using Tkinter library in Python. Here, the sensor ID drop-down box contains ID of all sensor. Now click on Generate Sensor Network button to create sensor network. In above screen, all red color circles are ordinary sensor and blue color circle is the base station. Now click on Initialization button to allow base station to find cluster heads and assign IDs to each sensor. So we can see sensors are divided into 3 clusters and the sensors which are closer to the base station are considered as cluster head and it's in green color. And the big circle represents one cluster and all sensors inside that big circle are considered as member of that cluster. All red color circles are ordinary sensor. Now click on Registration button to store all sensor details in blockchain. In above screen, after clicking on Registration button, we can see names of selected cluster head and the blockchain hash value assigned to each sensor. In this step, all sensor details will be stored in blockchain memory. In above screen, we can see before storing data, blockchain validates previous hash and current hash. And we can see current hash of previous sensor is matched with previous hash of new sensor. In text area, we can see registration details of each sensor stored in blockchain. Now enter some value in sense data and then click on Authentication and Send Data button to authenticate sending sensor and its neighbors. Upon successful validation, data will send to base station. So I'm selecting the sensor ID has 1 and sense data has 45. Now click on Authenticate and Send Data. So here we can see that the data is transferred from source sensor, that is 14, to the cluster head, that is CH1, and from the cluster head it is transferred to the base station. So here we can see in the text area, selected source sensor is 1 and selected cooperative sensor is 14, selected nearest cluster head to base station is 1 and received and decrypted data 45. So we can see that the data is received and decrypted. Now let us select one more sensor ID from the sensor drop down box. I'm selecting 3 and the sense data has 50. Now click on Authenticate and Send Data. So we can see that the data is transferred from source sensor 3 to the cooperative sensor 18 and to the cluster head CH28 and from the cluster head to the base station. And in the text area, we can see that the source sensor is 3 and the cooperative sensor is 18. Nearest cluster head is CH8 and the data is received by the base station. So we can see the message here, received and decrypted data. So in this way, by selecting the sensor ID and entering the sense data, we can transfer the data from the source sensor to the base station. Now click on Message Size Graph. In above graph, x-axis contains sensor type and y-axis represents size of message sent by the node type. In above graph, each sensor has to send only one packet and cluster head has to receive from various ordinary sensor. So its packet size will be more and base station has to receive data from only 3 cluster head. So its packet size also less compared to cluster head. Now close the graph. The conclusion of the project is, project proposes a hybrid blockchain-based identity authentication scheme to enhance security in IoT simulated environments where traditional trusted third-party authentication is impractical. The decentralized and immutable nature of blockchain improves security by reducing reliance on centralized entities. A hybrid blockchain model is developed, incorporating both a local chain and a public chain. The local chain handles internal communication and identity authentication within the network, while the public chain extends identity mutual authentication to various external communication scenarios. The project utilizes a hybrid blockchain for node identity authentication. Ordinary node identity authentication occurs within the local blockchain, while cluster head node identity authentication is accomplished using the public blockchain. The project conducts a thorough analysis of the hybrid blockchain-based identity authentication scheme, evaluating both security and performance. This analysis ensures the approach provides robust security measures while maintaining or enhancing system performance compared to traditional methods.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.